हेलो हेलो हेलो। सो आज हम लोग जो फिजिक्स का चैप्टर 2 है वो करने वाले हैं। एंड इट इज वर्क एनर्जी एंड पावर। वर्क एनर्जी पावर, क्वाइट अ गुड स्टार्ट, क्योंकि फोर्स वाला जो चैप्टर है वो खत्म होने के बाद आई गेस दिस इज द चैप्टर दैट यू शुड रियली पे अटेंशन, क्योंकि ये चैप्टर से क्वेश्चंस बहुत आते हैं और बहुत सारे न्यूमेरिकल्स हैं। मैं न्यूमेरिकल्स भी सॉल्व करूंगा। और इस चैप्टर के एंड तक जरूर देखना। ये चैप्टर का दो पार्ट बनेगा। दिस इज पार्ट वन, जिसमें मैं वर्क एनर्जी पावर तीनों को एक्सप्लेन करूंगा। और तीनों में हम लोग कुछ चीजें देखने वाले हैं, न्यूमेरिकल सॉल्व करने वाले हैं। ऑल ऑफ द थिंग्स आर गोइंग टू हैपन। अलोंग विद दैट हम लोग और एक चीज करेंगे, एंड दैट इज सेकेंड वाला जो पार्ट होगा उसमें कंजर्वेशन ऑफ एनर्जी एंड मेनी अदर थिंग्स, उसके बारे में डिस्कस करेंगे। बट फर्स्ट पार्ट में लेट्स डिस्कस more importantly about what is work, how it's done, and what is it actually. ठीक है। तो सो हम लोग का फर्स्ट थिंग इज what is work. In physics, work is done when an object is displaced from its mean position. अगर आप लोगों को डिस्प्लेसमेंट के बारे में नहीं पता तो पहले उसके डिस्कस कर लेते हैं। तो हम लोग यहाँ पर आता है डिस्प्लेसमेंट। दो चीजें होते हैं फिजिक्स में, एक होता है डिस्प्लेसमेंट और एक होता है डिस्टेंस। There are many people who get this thing very confused. What is displacement and what is distance? I'll make it clear. So let's say there is an object, okay, and this object moves from this position, this specific position, to this position. So if the object moves from this position to this position in a straight line, let's just say, let's just suppose that this is a straight line, okay? This is a straight line. If the object moves from this position, this is position A, this is position B. If the object moves from position A to position B, then we say that this is the displacement. Plus, this is also the distance. So let's just say this is 10 centimeter. So displacement is 10 centimeter and distance is also 10 centimeter. All right. But if I take this and make a different route like this, okay, so this is another route. So I have moved this object from A to B by not taking a straight path but taking another path which is not straight. Then this is the distance. This is not displacement, this is distance. So the shortest distance traveled is called displacement. Displacement is also a type of distance, but every distance is not displacement. Keep that in mind. Okay. Now, after you understood what is displacement, let's talk about work. We have already discussed what is force. If you have not watched the video, go and watch the video on force, chapter 1. After that, you should be watching this chapter 2 video. Otherwise, it won't be easy for you to understand. Let's move on. What is work? Work is said to be done. In physics, we say work is done when an object is moved from its mean position, or a moving object is stopped from its range of motion. So let's just say work is said to be done when force applied changes the state of motion of a body. So let's just say if I have an object, and this particular object has been provided force. F in this direction, from left to right direction. And the body moves from this position to this position. Okay. So if the body moves from position A to position B, because we applied force, then we say work is done. So work is done. But this is case 1. There can be a case 2. What can be the case 2? Let's just assume that there is a wall and I'm trying to apply force. I'm doing hard work, I'm trying to apply force, but will I be able to move the wall? I will not be able to move the wall. So the wall will not move. The wall will not move. So work is not done. Work is not done here. In physics, it is very simple. If you change the state of motion, if a body is at rest and you make the body move, or if the body is in motion and you make the body stop or whatever, if you change its state of motion, then you can say that work is done. Otherwise, in physics, we say work is not. Now, after discussing this, what is the what is the SI unit of work? In previous class, we discussed the SI unit. What will be the SI unit of work? In previous class, we discussed about the SI unit of force. What was the SI unit of force? The SI unit of force was Newton. Newton is the SI unit of force. Now, let's consider work. Work is denoted by capital W. Now, work is said to be done when force is applied and the body is displaced. So, we can say work is equals to force multiplied with displacement. All right. As you know this, displacement is what? It's nothing but distance, length. So the SI unit of that is meter. So we can say SI unit of force is Newton times meter. Therefore, SI unit of work is Newton meter. Alright. This is the SI unit of work. Newton meter is the SI unit of work. So Newton meter is the SI unit of work, and we say this Newton meter, we give it a name and we say it Joule, Joule, or we denote it by capital J. So from now on, remember that SI unit of work is Joule. Remember that. So SI unit of work is Joule, denoted by capital J. Now, next we move on to a topic where in the book it says work is said to be done. So if you look at the book, it says work is said to be done only when the force applied on a body makes the body move. That is, there is displacement of the body. Otherwise, work is not done. Alright, this is one thing. And in the book, you will also find you see the formula W equals to F times capital S. Capital S is used to denote displacement because generally we can get confused. D we use for distance and S we use for displacement. That makes it things a little easy. But I would rather say don't include more variables in physics. I don't like so many different kind of things. I'll use D instead of S. Okay, that's not a big deal for me. Now, the next is the measurement of force and everything else. So now there is one more thing. Force is we just found the SI unit of work. Now we also need to know that force is a vector quantity. I already mentioned what is a vector and scalar quantity. A vector quantity is a quantity which has both magnitude and direction. Displacement is also a vector quantity because it has a direction from point A to point B. There is a direction to it. So force is a vector quantity. B is also a vector quantity. When two vector quantities are multiplied, okay, when you try to find the product of two vector quantity, product means multiplication. When you try to find the product of two vector quantities, you get a scalar quantity. So we can say work is a scalar quantity. All right. So work is a scalar quantity. Now, there is one simple condition which I applied, that if work was applied in a straight line, like if I apply the force and the body moves in a straight line. But what if the body is at an angle? So if there is this object of mine and this object is pushed at a particular angle. Let's say this is the angle and I'm applying the force. I'm not applying the force like I'm not applying it like this. I'm applying the force like this. All right. So I'll just erase this. So what if I'm applying the force in this direction, but the body will move in this direction. All right. And we'll see the body comes here. You can try it. You can try moving a body, push the body straight, but the body will move upwards. So this is a little different case. Case one. So I'm applying force on a body at a slope. This is a slope. So this has an angle. We can name the angle theta. We don't know what the angle is. The angle could be anything. It could be 30 degree, 45 degree, 90 degree. Uh, it could be anything. So case one. Okay. We take this and we apply the force in this manner. Not necessarily case one, whatever you name it. So we are applying the force at an angle. So you see, you're applying the force in this direction, but the body is moving in this direction. So this is creating an angle, theta angle. All right. This angle is very important. Why? Because right now we saw that the formula of force was, sorry, formula of work was F times distance, displacement, sorry. So work was force multiplied with distance or displacement. So when you are applying the force at a particular angle, this displacement and this force gets changed a little bit. How? So what is the displacement of the object? Instead of D, so for example, this is, let's name this triangle A, B, and C. From Pythagoras theorem and trigonometry, if you have studied trigonometry, you will know that this theta has sine, cos, tan, and everything. Cos of theta is base by hypotenuse. If you don't know, अगर आप लोगों को पता नहीं है, let me explain. So if there is a right angle triangle, this is the base, this is the hypotenuse, and this is the perpendicular, and this is angle theta. Okay. Now in this triangle, angle theta is this. This is our base, this is our perpendicular, and this is our hypotenuse. So in this triangle, particular triangle, AC is what? AC is the displacement D. This is displacement. AC is the displacement. We can say cos theta is base times hypotenuse. Base is AB upon hypotenuse, which is D. All right. So I can say AB equals to cos theta times D. I can actually cross multiply this. Okay. From this expression, what you can conclude is that you need to find the displacement of the object from this position to this position. The object has moved from this position, position B, but at an angle. You can see this. In this particular example, the work will be F times AB. And what did we find just now? That AB is d cos theta, d cos theta. So you can also say that work done in this scenario will be F cos theta into d, or you can say just F times d cos theta. Now, in your book, the formula is given like this: W is equals to F times s cos theta. Okay, s represents the d here, the displacement. I'm using d for better understanding or easier understanding. There are some special cases. In your book, it's mentioned special cases. So what are those special cases? Okay, there is one case. One case is if displacement is in the direction of force. So if force for case is displacement in the direction of force. So displacement in the direction of force, that means what? So if I have an object and this is the direction of force I'm applying, and this is where the direction is, the displacement is, then we say that work done is positive. So work done will be positive. Work done is positive here. But if this and this here means the cos, the angle. So this is force and this is the displacement. So there is no angle here. So we say that cos theta is equals to 0 degree. This was case 1. Cos theta is 0 degree. Now next, when displacement displacement at 90-degree angle means cos theta is equals to 90 degree. What was the value of cos 90 degree? The cos 90-degree value was 0. So cos 90 degree is 0. Therefore, so if there is an object and if I am applying the force in this direction, but the body wants to move in the upper direction. So this force is this and this is displacement. This angle is 90 degree. So work done will be work done. What was work done? F times d cos theta. Cos theta is 0. That means force into 0. So no matter how much force you apply, work done will be 0. So work done is 0. So we say work done is nothing but 0 or null. There is no work done here. Now there is another one, case 3. Case 3 is that if the displacement d is opposite to force. So for example, you are applying the force in this direction. This is force, but the displacement, the body wants to move in this direction. So what you're doing, you're opposing the displacement. So work done will be negative. That means over here we see cos theta. Cos theta is 180 degree. 180 degree. All right. The whole 180 degree. So therefore we say cos, cos 180 degree is minus 1. Therefore, work done will be negative. All right. So this is the work done. So there are three cases. Let me explain once again. If cos theta is 0 degree, work done is positive. If cos theta is 90 degree, work done will be 0. There will be no work done, no matter how much force you are applying. And if cos theta is 180 degree, then work done will be negative. These are the three special cases. Now we see there are some examples of these three cases. For example, for case 3, work done is negative. When does that happen? So when you're trying to stop an object, when there is a cycle, it's coming towards you and you're trying to stop it, then work done is negative. When is work done 0 in the 90-degree angle case? So if you're applying work in a, for example, if there is the object and you're applying force in this direction, the object will not move because there is a floor beneath it. So there is no way to move, but only the sideways direction. But you're applying force in this direction. This is your application of force. Will the object move? The object won't move. This happens when you're trying to stop an object directly at you. Okay, if there is an object, it is moving in this direction, and you are applying force to stop it, then you say work done is negative. I guess I'm trying to be as clear as possible. Now there is one more case. What is work done for falling objects? Falling objects. So for falling objects, there is another force that if you don't apply any force, if there is a free falling object, what is a free fall? Free fall is if there is an object, let's just say this is an object, and I've not applied any force, but I'm just going to leave this object as it is. So I'll leave it. It falls. This object falls because of gravity. Now, when I'm not applying any force, I'm just leaving the object, it falls. It is a free fall. Then we say that there is a force that's acting on it, and that is called gravity. And not just gravity, acceleration due to gravity. So we use there are two things, there are two terms for gravity. There is a capital G and there is a small g. We use the small g for acceleration due to gravity. So if there is an object and it's falling downwards, this is where it falls. This is the ground. All right. Now this object is falling under the force of gravity, small g. And there is a specific value that you need to remember. Always remember this. Acceleration due to gravity. Gravity is small g is acceleration. If you haven't taken down notes, please take down notes. This is acceleration due gravity. Now Earth has a specific acceleration of gravity. Another planets have other accelerations due to gravity. It's the amount of force that is exerted by the planet to pull an object. This over here is 9.8 meter per second square, or we write it like this: 9.8 meters second square inverse. These both are same things. If you are not habituated to write second per square in this manner, write it like this. There is no issue in it. But in senior classes, you have to have the practice of writing the per square in this manner, or per cube, or whatever you're writing in this manner, in a negative manner. Why it happens? I think you should be attending the math classes more often, because there you will understand. Leaving that aside, let's focus here. So now, if the object is falling downwards, it's falling because of the acceleration due to gravity. So, first of all, there is g, small g involved. There is a height involved, and also there is the mass m of the object. All right. So these all things are happening here. There is m, that is the mass. This is the mass of the object. There is small g, which is acceleration due to gravity, which is 9.8 meter per second square. And then there is height. The height could be said as small d. It's the same thing. Displacement, that is what height is. So we can say if there is no force applied, if I don't apply any kind of force, then we can say that work done here is mgh. Mg represents force. Force is mass times acceleration due to gravity. This is the force that is on the body, that happens automatically because of the force of gravity. H is displacement. So now you understand what is happening here. But if I am applying an extra force, if I am throwing the object downwards in a specific manner, then there is a difference. Then you have to multiply another force with it. But for right now, I guess this is what it is. So work done is mgh. Now our next discussion topic is power. Very important. Power. What is power? Where do you see power? So our next topic of discussion is power. Power. सबको power चाहिए, क्यों ना? तो power फिजिक्स के टर्म्स में क्या है? What is the proper terminology for power? To be very gentle with the terms, power in the terms of physics, we say power is nothing but work done per second. As simple as that. So we can say power P, capital P, is equals to work done per second. So every second work which is done, we say power. So we can also say joule per second. I'm going to write it as J per So this is what power is. Power is work done in unit time. This is the definition of power, or more simply, rate of work done. This is also one definition. This is also one definition. Whatever fits you best, whatever you think is easier to remember, just write it down. You don't have to. You never have to write big definitions for these simple terms. Always try to remember things in as easy way as possible. Power, rate of doing work. Rate means what? Rate means time taken to do the work. So work done per second. Okay. So power is joule per second. As simple as that. Now, power has many different types of measurements. Joule per second is a very small quantity, very, very small quantity. We don't use that much small quantity. We use power in much more larger quantities. So we generally use kilowatt. Okay, we use megawatt and we use gigawatts for power. This is the SI unit, joule per second. This is the SI unit of power. There is also a CGS unit. CGS. CGS means centimeter gram second. So in centimeter gram second, the CGS unit of power is energy on or energy, I guess. Energy. Energy per second. So ERG per second. This is even smaller quantity of power. But we generally use the higher quantities of power. So there is a relationship between them, and you also get horsepower. There is another one which is called horsepower. Horsepower. We generally use these terms for cars, bikes, not powers, horsepower. Horsepower. Now I'm going to give you a proper relation between these. So I don't generally remember them. I'll give you the relationship. The relationship is this: 1 watt, so not kilowatt, 1 watt, capital W. 1 watt is 1 joule per second. That this is very simple to remember. 1 joule per second, that is 1 watt. Now we measure in kilowatts, megawatts. Okay, so 1 joule per second or 1 watt is 10 to the power 7 energy per second. Okay, 1000 what is that? 1000 watts is 1 kilowatt. So 1000 watt is 1 kilowatt, and 1000 kilowatt is 1 megawatt. Okay, mega, I guess MW, small m is used, not the capital M. I'm going to use this megawatt, and 1000 megawatt is 1 gigawatt. And this is what you need to remember the most. This is the important part. You need to remember this. This is important. You need to remember this. This is important. You need to remember this. And then you have to remember horsepower. 1 HP horsepower is how many kilowatts? One around 700, 746 watts, which is equals to 0.746 kilowatt. So this is also important. So whichever is important, just memorize them. Otherwise, just leave. Okay. The rest of the parts are not that important. Always remember, multiply. If you are going for the higher quantity in kilowatts, from kilowatts to megawatts to gigawatts, multiply with it with 1000. That's it. Now, if you see in your book, there is a definition, proper difference given between work done and power. So work and power, the SI units are different. SI unit of work is joule, SI unit of power is watt, which is joule per second. Work done does not depend on time. So it does not depend on what time you're taking to complete the work, it's still work. But when you are considering power, it depends on time. So if you are giving a particular amount of work, if you are doing a particular amount of work at a particular amount of time, that is the power. So I'll explain. So if I am doing a type of work, so let's just say I'm doing work and I'm doing a work of 1 joule in 2 seconds. That is 0.5 watts. How? 1 joule in 2 seconds is 1 joule per 2 second. So how many joule in 1 second? 0.5 joule per second, which is watt. Now you understand? So watt depends on a, sorry, I mean power depends on time. On the other hand, work does not depend on time. This is one difference. The next one is the definition. Okay, you all know work done is equal to the force applied in the mm, force applied multiplied with the direction, whereas power is the amount of work done in a particular time or rate of work done. Or I've already given you a definition, the more simpler one, work done in unit time. That is the definition of power and work. And the difference is there is this one is important. Work, power, difference. Remember them. This is important. These questions generally come in exam. All right. Now we move on to our next topic, which is energy. What is energy? Energy. We all have heard about energy. We all discuss about energy. We say plants get the energy. We get energy from food and many more things. So, what is energy? Energy is the capacity of a body to do work. As simple as that. The capacity of doing work. So, work done in unit time, rate of doing work is power, whereas capacity of doing work is energy. So, in simple terms, energy is capacity to do work. This is energy. I'll just highlight it. All right, capacity to do work is called energy. A body capable of doing work is said to possess energy. The energy possessed by a body is measured by the amount of work that the body can perform. When a body does work, its energy decreases, while if the work is done on the body, its energy increases. It means that whenever work is done, there is always a transfer of energy. Explain. This is a body. I'm applying force. The body is moving from this position to this position. This is A and this is B. So me, your handsome teacher, Gulfam, does the work. He moves the body from this position to this position. So he is losing what? He's losing energy. So from me, energy is getting transferred to here. That means if I am doing work, I'm losing energy. And on the body for on which I'm doing work, it is gaining energy. So you might have a question that if I am transferring the energy, what happens to the energy? Well, that is a part of discussion where we discuss energy can neither be created nor destroyed, and that is the conservation of energy. But I hope that we'll be discussing that soon in the next part. But right now, let me give you a little understanding of what is happening. So I'm transferring the energy, I'm giving the energy to the body by doing the work. What does the body do with the energy? The body changes the energy in other forms. For example, friction is involved. If I'm moving a body in a particular plane, there is a friction. So energy is getting transferred into heat because there is friction, heat is mm, created. So it's not created out of nothing. Because I'm providing energy, my energy to move the body, it is creating a heat. The next thing is happening, next thing what is happening, the energy is getting converted into the displacement. So by which I mean that the body is displacing from its mean position to other position. Over there, you get the transfer of energy. Now this body will keep on moving until and unless this body is stopped. All right, these are the laws of motion, but we are not going to discuss in depth. There are other chapters to discuss. So this body gains energy, whereas I lose energy. All right, I guess this is quite understandable for you all. Moving on to our topic of discussion. Mm, Energy of a body is the capacity to work, as simple as that. There are units of energy, so we measure energy again in joule. All right, so there was a little difference of energy and power. Power, rate of doing work, energy, capacity of doing work. You see the difference? Now, this is the energy, all right? Now, there are units of energy. There are units of energy. So what are the units of energy? Let's discuss that. So joule, 1 joule. 1 joule is what? 1 watt. Sorry, someone is calling me. Well, I will wait for him. Moving on. So 1 joule, we measure power using joule per second, whereas work energy is measured in just joule. So 1 joule is one, sorry, 1 joule is 10 to the power 7 ERG energy. And then there are bigger units, which is kilowatt hour and watt hour. So 1 joule is 1 watt hour. Kilowatt hour is, I'll explain. So sorry, 1 watt hour is equals to 1 joule times 1 hour. And the SI unit of time is second. So 1 hour, we cannot write it in hour. We have to write in second into 3600, I believe. Yes, 3600 seconds, which is 3600 joule second. Next, we discuss watt hour. Watt hour, not watt hour. Watt hour is 1 watt times 1 hour. As simple as that. So 1 watt is what? 1 joule per second, and 1 hour is 3600 seconds per second, and second will cancel each other. All right. We get 1 joule. If you have a question why it cancels each other, if you don't understand, comment it below why. I'll explain. So joule times 3600, which will give me 3600 joule. 1 watt hour is 3600 joule. And when if you want to convert it in kilowatt hour, so kilowatt hour will be multiplied for, I'll explain, wait. So kilowatt, 1000 watt equals to 1 kilowatt. So therefore, kilowatt hour means 3600. One, I'll write it down. 1000 watts equals to 1 kilowatt. So 1 kilowatt is what? 1 divided by 1000, or whatever 1 or x, whatever is there. So here it is 3600 divided by 1000 joule, which is 3.6. Point here, point here, point here. 3.6 joule. That is 1 kilowatt. And like this, you can find out the gigawatt, which will be 0.0036 joule, and then the gigawatts, sorry, megawatt is 0.036 joule, and gigawatt will be more. These are the things, and there is another one, calorie. Calorie. We say now we burn calories when we are working out. That is also energy. We are burning energy. So we measure it in calories. So what is calorie? A calorie is the amount of energy required to burn to change the form of water from liquid to water vapor, or to be very easy to explain, to convert 1 gram of water into water vapor. The amount of energy required to convert 1 gram of water into water vapor is called calorie. Calorie is related to joule in this manner. One calorie is equals to 4 point something, 4.18 joule. That is 1 calorie. And 1 kilocalorie is equals to 4180 joule, because kilo means multiply it with 1000. These are the units that you need to memorize a little bit. If you ask me, did I memorize? I never memorized them from my heart. I always memorize them just before the exam, because why to put so much pressure in your mind? See, try to understand how the conversion works. Kilo, multiply it with 1000. Change the kilo into smaller unit, divide it with 1000. As simple as that. Once you get that thing in your mind, just remember one thing. The rest of it doesn't matter. So this topic is discussed. Then there is the difference between energy and power. That is also important. You have to study that. And what else do we have? We have electron volt, EV. So there is one electron volt. This is a very small quantity. Okay, electron volt. This is also energy, but this is a very, very small quantity. The energy of atomic particles is very small, so it is measured in electron volt. 1 eV is the energy gained by an electron when it is accelerated through a potential difference of 1 volt. If you're not understanding, don't worry, you will understand in later chapters. Right now, just understand that 1 energy is the amount of work required for the potential difference of 1 volt for an electron. So 1 eV is 1.6 into 10 to the power negative 19. 1.6 multiplied by 10 to the power negative 19 joule. I hope the 19 is clear. I just erase it. 1.6 into 10 to the power negative 19 joule. This, I'm telling you, the examiners or the ones who make the paper, they will somehow include this. I don't know what they do, what kind of things they are making, what questions they are doing, but they will somehow include this question, somehow include a question where you have to convert it to electron volt or from electron volt to joule. Always remember 1.6 into 10 to the power minus 19. Now this 1.6 into 10 to the power minus 19, if you remember it, it will be very useful in chemistry, because this one comes in chemistry very often. Now, read the energy power difference. What is the difference between energy and power? There are three differences given in your book, okay, in your page number 25. Remember those, and then I will suggest you to solve all the question answers. Okay, I'm also going to write some of the most important questions. What are the most important questions? If you go to page number 27. If you go to page number 27, you will find there are some questions given to you. Now there are some more very, very important questions. Question number 3 is important. Then question number 20. Wait a minute. Question number 7, 8, 9, and 10, 13, 17, 29. All right. These questions are important and from numericals. I'll just say all. Practice every numerical as possible. As many numericals as possible, practice them. There are, I guess, 16 numericals. If you have any issue with any numerical, comment it below that you are not able to solve a numerical. Comment down the numerical that you are not able to solve. Okay, try it first. If you are not able to solve the numerical, tell me, comment it below. I'll try to make a short video, like in the YouTube shorts. I'll make a short video for that specific numerical and I'll upload it. You can watch that video. Simple to understand. So part 1 is over. Wait for part 2, which will be uploaded in the next video. I hope you're enjoying your days, and board exams are coming near. Try to be a little serious with your studies, and if you think that you're just going to come on YouTube and study just the day before exam, you're doing a bit of mistake. Don't do that. Okay, try to understand these topics. These are very important and fun to read. I understand sometimes studies can be boring, but believe me, It can be fun too. You can actually have a lot of fun while studying, and you don't have to always memorize every single thing. Why to memorize? Technology is there for that. Don't memorize everything, try to understand the topic. I hope you enjoyed the video. If you enjoyed the video, give it a like, subscribe to the channel. Do not forget to hit the notification bell icon, ting ting, to get notified whenever new video is coming out. And winter season is here. I hope you're all enjoying your winters, and Christmas is also coming. So enjoy, but pay attention a little bit to your studies. Peace.